Okay, homework 10 is available now. It includes a couple of problems that are related to what we discussed in class last time. Homework 10 also has some problems that are really just algebra word problems. I mean, there's no specialized skill or knowledge needed to solve, for example, problem 3, 4, and 5. So there's no need to wait until you learn some certain technique for that or receive an Excel template. It's just thinking numerically, and I guess the big idea on some of these questions is setting the costs equal to the revenues. And as long as you can just balance those, you'll be able to find the operating point that's described in the problem statement. So I just wanted to point that out. The second exam, of course, is Monday of next week, and I'll just revisit the slide that I already showed you on Monday so that we can all be on the same page on what the expectations are for that. Today we're going to be talking about break-even analysis, and this is back into some material that's covered by the textbook, Chapter 13, for those who are following along. So just to reiterate what I mentioned on Monday regarding the exam, you should bring your laptop because at least one of the questions, and probably multiple, you'll be asked to use Microsoft Excel. But when you use Excel, you'll need to start with the blank workbook. So you shouldn't open an existing homework file. You shouldn't use a previously solved in-class exercise or even a template file. You're just starting from scratch with Excel. And so that being the case, it may be worth your while to make some notes on the blank page that you're allowed to fill in however you like, just with a step-by-step procedure. If you want to remind yourself on what you do, for example, external rate of return, or maybe you'd want to list the column titles that you would utilize for incremental benefit cost analysis, just whatever techniques you think you may be called upon to apply using Excel, and you need a reminder, you should include that on the notes page. So after thinking about it, does anybody have any questions about the exam?
Okay, for the note page, like, is there something, is there stuff like we're not allowed to put on that note page? Like, we could literally just
You can put anything you want onto the page.
like, I could just take it like a screen clipping of like the example.
You can do screenshots, yeah, you can do like encouraging note from your grandma, whatever will help you for the test, put it on there.
That just worries me that the test is gonna be your note.
This is one of those moments you don't ask questions.
Sorry. Yeah.
All right.
I'm done.
Let's move on. This is a really important figure that we talked in some conceptual detail in class on Monday, but we didn't get to the point where we were able to graph the in-class exercise that we were solving. So I've put the solution to in-class exercise onto Blackboard. Go ahead and download that now, and let's go through the process together of taking the data and setting up a figure that looks similar to this. Because what we want to be able to graph for the homework assignment is revenue, cost, and profit. So let's just, in case it's been a while since you made graphs in Excel, let's go over that together. So if you go to Blackboard, it is just in the root of our course content page down at the bottom, ICE 27 solution. So if you download and open that, it's what we're going to start with. So this is the one where we knew our fixed costs, our variable costs per unit. We knew, based on some sort of a market research study that had been done, what is the price at which no one would buy any, and how much of a reduction in price causes the demand to increase by 1 unit. So those are the variables that we use to calculate for a range of values. Now, over here, I got to emphasize this again, that we don't know at the outset what the range of profitable demand is going to be. I mean, you could solve that using the formula. Remember that we do have an equation that you could calculate the break-even points in advance. But if you hadn't, what you need to do is just have a bunch of different demand values that we're then going to find out what is the price associated with generating that amount of demand for a certain price, and for a certain demand, how much revenue is being generated, that just being the product of the two. The costs being the fixed costs plus the variable costs, and then profit being defined as revenue minus cost. So that's how we generated this data. And we didn't necessarily know in advance how much demand it would take, but we could edit that along the way. You remember that we identified the break-even points and just checked to make sure that those actually were the point at which we went from negative profit to positive profit and so on. Okay, so making a figure here in Excel on the Insert tab, we're going to do Insert, and you'll notice that under Charts, there's a lot of different options, and we want to select the drop-down box for a scatter. So we're going to select the kind of scatter plot that doesn't include the data points and does curve the lines. So this one, scatter with smooth lines, because we don't necessarily want to see those data points as we graph the data. Those exist only to provide the underlying basis for the smooth lines that we want to be there. So scatter with smooth lines. All right, so it's blank. We need to tell it what data to include in the graph. So if you just click here on the graph itself, the empty graph at this point, and then select data. So it's under here under the chart design tab. When you actually click the graph, it'll bring up different menus across the top. There's format and chart design. We're under chart design, and we're going to select data. So we're going to have 3 series on this. We're going to have revenue, cost, and profit. So we're going to add a series, and then let's type in the name here, revenue, into the series name. And for the values that we're going to include on the X, select the range. So click on that arrow up button, and that's going to allow us to click somewhere in the spreadsheet to select which values should be the range of X values. And that's going to be our demand. We want the demand to be on the horizontal axis. So click on the arrow and then highlight demand. Okay. Now we want to define the vertical axis, and so the Y series is going to be the values associated with revenue. So I'm just going to highlight that range of data which is under the revenue title. Okay. And we should have that nice curve that we are expecting. That characteristic point where there's some maximum revenue followed by which the revenue is declining, even though our sales are going up because the prices dropped off so precipitously. So any questions so far? Okay. So next, add another series. And this one we're going to enter the title cost and do the same thing as before. So it's just another series on the same figure. So we're going to select for the X data, demand. For the Y data, this time it will be the cost. Okay, this is starting to look pretty familiar. You know, we had the fixed costs, the variable costs. We can already see where is our break-even points at which the revenue exceeds the cost. There's 2 of them. So that's the range of profitable demand, where the blue line is above the orange line. Any questions so far? The third figure is going to make it look quite a lot different because we've got negative values in the third series. We're going to adjust as soon as it, it automatically decides what to use as the range of values, and we'll fix it up to make it look better. But I just wanted to give you the advance warning that when we add a third series, which is profit, And again, select demand values for our X. And this time selecting the profit values for the Y. Now you'll see that we've got some values above 0, some values below 0. And that portion of the gray line that is above 0 coincides with our break-even points. So, I mean, that makes sense. Profit is the difference between revenue and cost. So this is what our figure looks like right now. And we're going to make some adjustments just to improve it. Now, I only want to see what's positive values. I don't want to see the negative profit because I already know that the profit will be negative in certain sense. And so right-click on the vertical axis, just any one of these numbers, so like 400,000, if you right-click on it, we're going to select the Format Axis option. And instead of having it automatically select the bounds of the range, we'll just force it to 0 for the minimum. So if you force it to 0, then all of a sudden the graph looks a lot better. We're only visualizing those positive values above 0. Okay. So we'll do a similar thing. For some reason, it thought that we might want to see negative 2,000 as the leftmost bounds of the horizontal axis. I don't know why it thought that because our demand always starts at 0, but I guess we can override it. Just click on one of the numbers on the horizontal axis, right-click, and then select Format Axis. Oh, it looks like it's already popped it up on the right-hand side there, even without us choosing. So instead of negative 2,000, just start it at 0. Okay. So this is starting to look pretty good. We should put labels on the axes and units as well. So let's see if we can add that. So click on the graph, and then off to the side here where it says plus, see that little plus button? Chart elements. Now there's multiple ways to do this. If you know how to do it a different way, you don't have to follow my approach, but I'm going to add axis titles. And so right now, what sort of elements exist on the chart? It's got axes and grid lines. You'll notice there's no legend, there's no trend line, data labels, that's fine. But I would like to have titles. So it just, as soon as you enable titles, now it has axis title and axis title. I can do better than that. There's demand, and the units, this is units sold per month, I believe was the, it was a per month thing in the problem statement if I'm remembering correctly. And then the vertical axis, I guess we'd just call that amount in dollars because, you know, it's going to be revenue, cost, and profit all on the same. So maybe the vertical axis title isn't so important, but I would like to see if I can change it to dollars. Let's see, if format axis number, instead of general, I want it to be currency. That looks good. And I don't have to show decimal places. You know, like if it's increments of 100,000, there's no need to specify cents. So I'll do 0 on the decimal places. So I think, I could, if I was going to give this an axis title, I'd call it amount. But, I mean, obviously it's an amount. So I'm just going to delete that. I don't think it adds any value. But it may not be immediately obvious to somebody who doesn't already know what these different colors represent. Like, of course, we know that the blue one is revenue, the orange one is cost, and the gray one is profit. But let's put in a legend just so that there's no uncertainty. Legend. All right, so now it's defined. And I don't like gray for profit. That's not enthusiastic enough for something like profit. That should probably be green, right? For money. So you can change the colors if you like, but that's just kind of a an overview of how we would create that figure in Excel that we saw conceptually here. We can't differentiate between the fixed costs and the variable costs. I mean, we could create a separate column, but I think this is good enough. So any final questions on this illustration before we move on to today's material? If I zipped through anything too quickly, remember that the recording will be on YouTube immediately after class. So you could, if you want, go through that later. All right. We already, in the previous class, talked about fixed costs versus variable costs. Fixed costs are those which don't change as a function of how many units are being made each month, or each day, or each year. So in these pictures, one is making Twinkies, one is making circuit boards. The fixed costs might be the machinery that you have to purchase just to make the things. Or the fixed cost could be the safety gear that the employees are wearing, or the rent for the facility. So there's a variety of different things, including employee salary for people who get paid on a monthly basis who aren't hourly employees. So management is often considered a fixed cost. The variable costs are those which do change based on how many you're making. So it could be the ingredients that go into a Twinkie, like preservatives and sugar and so on. It could be the cost of the packaging, the plastic packaging, warranty costs. If you are selling something that has a warranty like an electronic component, the more that you make, the higher your warranty costs go. Most of the time, variable costs are linear, which means that there's a one-to-one relationship between how much additional cost you have and how much additional productivity you're doing. So the fixed costs don't change as a function of productivity, and the variable costs are linear, meaning that the variable costs are just some fixed variable cost per unit multiplied by the number of units per year which are being produced. So that's a linear cost relationship. There are, however, nonlinear cost relationships. And so what this would indicate is that as the number of units per year increases, the variable cost per unit is going down because that curve is tapering out, which means that the cost per unit is decreasing. So think about what are the factors that could cause a nonlinearity as is pictured here, where it's getting cheaper per unit. Bulk purchases. Yeah, we talked about how buying a rail car of flour is less expensive per pound than buying a bag of flour at the store. So that could be one factor. There are nonlinearities that make something increasingly expensive, though, the more of it you make. Can you think of an example where instead of it getting cheaper, the more you make, it would become more expensive as the level of production increases?
Limited resources.
Okay, if there's limited resources and you're trying to make so much that now you're bidding up the price of the raw materials. So, for example, does anybody know what the SR-71 is? It's a jet that they used to use in the 50s and 60s and up through the late 80s for reconnaissance flights. It was very fast. And it was made out of titanium. The CIA designed and built the first few, then the Air Force operated them. But it was made out of titanium, which is at the time was really hard to get a hold of because the majority of titanium was in the Soviet Union. So they had to really be kind of sneaky and cautious about buying the titanium, and they needed a lot of it for these SR-71 planes because they would very quickly exhaust the non-Soviet supply, and they would have made it so expensive that they wouldn't have been able to afford the planes. So they had to buy it discreetly without people really knowing what all that titanium was being purchased for, to avoid the cost per pound of titanium going up. Another is like in the case of buildings. If you think about a skyscraper, building a 10-floor skyscraper, your cost per unit of construction is going to be less than making a 20-floor skyscraper because of the added complexity, because of just the risks and limitations of building vertically. The project becomes more complex and more expensive. In water and wastewater treatment, which is one of the things I've worked with over the years, when they have sand filters for drying sludge, like whether you're producing water or wastewater, you end up with a wet sludge that needs to be dried out before it's disposed of. And so sludge beds, which is just some place to dry out the sand, become increasingly expensive the larger they are, because similar to construction of buildings, that it's just not as convenient to grade such a wide area, and putting it all together is more complex. So there are some things where it's more expensive, and you can't always assume a linear cost relationship. So that's something you have to pay attention to when you're doing cost estimates. This figure, what we've done here in this figure is zoomed in on this. So let me zoom in by, we can adjust what we're looking at in terms of the scale. So if I said, let's just go through 2000. Okay, so now we see that crossover point. And I guess if I don't need to see that much vertical as well, I could just say through maybe 400,000. All right. So this is the crossover point where the revenue finally goes higher than the costs. So that's the same thing that we're looking at in this figure, is the crossover point at which the revenue is greater than the costs, and so there's some profit, the distance between the two. So keep in mind that revenue is the number of items sold multiplied by the sales price per item. So there's some break-even point which defines where those 2 points cross. But if your unit price decreases, then the break-even point is going to shift. Think about how steep this cost line is. There's fixed costs, and then there's variable cost per unit. So if your material costs go up, that's going to make the line steeper, and that would push the crossover point to the right. Whereas if your cost per unit decreases, then that would shift the break-even point to the left. So that's what's being depicted in this image, is when the variable costs are reduced, meaning that your variable cost per unit is lower, then the fixed costs in this illustration have remained the same. If the fixed costs also decrease, then that would push the break-even point even further to the left. But here we had some previous break-even point, which was with the higher prices. So if the costs are lower, that means that you don't have to sell as many items before you begin that range of profitable demand. So the thing to remember is that if you have a linear relationship between production and cost, and then you decrease the variable cost per unit, then the break-even point moves left. So you need to be able to kind of reason through why the break-even point would decrease, why the break-even point would increase if the variable price per unit increases. You'll have a couple of concept questions on the exam. Okay, so that's one way to describe break-even. The word break-even can mean break-even between revenue and costs, and that's what is being depicted here, the revenue versus cost break-even point. But there's another way to use the word break-even. Another way to think about it is when you have two different options for equipment, and you're trying to decide which equipment option is least costly. So that's what this is about. Two different alternatives that could be used to achieve the same aim. So two different pieces of equipment, and alternative one has a low fixed cost So it's cheaper to purchase outright, but it has a higher variable cost of operation, alternative one. So it might be like a less sophisticated piece of machinery, but it requires maybe more manual interaction. Maybe the materials for it are more costly, but this is a steeper line, which just reflects that it has higher variable costs. Whereas alternative two in this conceptual illustration has a higher initial fixed cost, but it's a shallow line. And so that relatively non-steep slope just means that it's not as expensive per unit to utilize alternative two. So there's one alternative with lower fixed, another with lower variable. And which of the two equipment pieces we should buy depends on what we expect our level of demand to be. Like if you expect that you're not going to be making very many units, then you should choose alternative one. Like if there's not going to be much demand, it has the cheaper cost at low demand. But there's some crossover point at which it actually is cheaper to use alternative two, that second equipment piece, even though it's more expensive initially. If you're making a lot of things, then it covers that higher initial cost with the lower operating costs. So which alternative to select is determined by the level of production, and that is what we're going to be looking at in today's in-class exercises. We're going to be trying to play around with the idea that there's two different alternatives. One of them has lower fixed costs, one has lower variable costs, and trying to identify the break-even point, which tells you whether to choose option one or option two for the equipment. Okay, there's another template file in Blackboard beneath the one that you just pulled up for that in-class exercise. It's the starting file for in-class exercise 28. And if you download that, it will save you from just typing in and formatting some cells. And what we're going to try and do is consider two different pieces of equipment, a computer-controlled machine and a manual-controlled machine, and determine under what circumstances should we go for one versus the other. The layout for it's on the back side of the paper if you just want to glance at what does that template look like. But it's here on Blackboard at the bottom. All right, so there's a series of questions it's asking, and I'm not going to give you too much instruction up front on how to format this. I'd like to see if you can reason through it and figure things out. It comes back to the question, though, of capital recovery. So remember, what are the two components of capital recovery?
It's the salvage and the salvage.
Salvage value is one of them. The initial purchase price is the other, right? So what you're doing with capital recovery is you're using the PMT function. So you're annualizing both the present value of the initial purchase and the future value of the salvage. So when you're using the capital recovery, you do equals PMT, and you put both in the PV and the FV in the same function. And then it'll tell you what's the capital recovery cost for the equipment. Just that one hint I wanted to give you before I turn you loose on this. I'm just going to put in some of the values. I'm not going to narrate through, so keep working if you like, but if you are stuck on something, you can watch what I'm doing. Just a second.
Is the fixed cost supposed to be negative? Oh, I didn't put in a negative value for some reason.
Just to revisit, all of this was just given data, just the statistics about each piece of equipment and how much it costs to operate it. And then the how many hours per year we're going to operate it. If we need 1,000 units and we can do 3 units per hour, we don't need to run the factory 24/7. We only need to run the factory enough hours to generate 1,000 units per year. So that's simply going to be the number of units per year divided by units per hour, and then that'll tell you how many hours it should be operating. So option 2 requires more hours, but it was the one that's cheaper up front. So in the capital recovery, being the fixed costs, it's hard to see because it's so small, but what I've put into the first field is the rate. Then the N is just the predictive life of the equipment, 10 years for option 1, 7 years for the other option. What goes into the PV field is the minus of the first cost. And then what goes into the FV field is the minus of the salvage value. And I did the minus to ensure that my fixed cost had a negative value. The variable cost is simply just the number of hours that it's operating by the labor costs per hour, and then the total is the sum of the two. So at 1,000 units per year, then it looks like the cheaper option is option 2. No, sorry. Yeah. Option 2 is the cheaper one. If I highlight both of these, so highlight both of them, let's see if we can do the conditional formatting. So I've highlighted both of the options for the total cost. I'm going to conditional formatting, new rule, and format only the top or bottom ranked values. So I want it to be the top one. So it's going to choose the larger, meaning the less costly option. The top one, and then here for format, choose bold. Not strike through. I don't know why it would do strike through. Bold. Okay, so okay, and now it's choosing, it's just drawing the eye to the fact that option 2 is the larger of the two numbers, meaning the less negative of the cost.
Where are you going to do that?
Highlight the 2.
Yes.
Conditional formatting on the Home tab. So Home, then conditional formatting,
Okay.
new rule, and then only top or bottom ranked values. And we want the top 1 to be formatted as bold. Okay. So that's what happens if we're doing 1,000 per year. What if it's 3,000 per year? All we're going to have to do is change this first value. So let me just write down at 1,000 units per year. Oh, I did that strike through thing. That's funny. The cheapest is option 2, which is 339, 547, and 67. That's really irritating. Let me change that formatting so that it's not doing the strike through. Okay, that's better. Now, what about 3,000 units? I'm going to change that from 1,000. Now at 3,000, it automatically updates everything, and now option 1 is cheaper. Now, how to find the break-even point. This is maybe the most important part. So if I can have your attention, we've still got 1 more minute. To find the break-even point, this cost difference between options, we want to be 0. So I could manually find I could play around with the output level, or I can do goal seek. So here, data, what if analysis, goal seek. I'm going to set the difference between the options to 0 by changing the output. And so it's going to play around with what is the number of units that makes the two costs the same. So if we have less than 2,046 units, we should use option 2. If we have more than 2,046 units, then we should choose option 1 of the equipment item. So that is the break even between alternatives, 2,046. All right, that's it for today. I'll see you in class on Friday.